Okay. For part B, number 27, again, we start with the easy stuff. Copper by itself, no charge. We know that's going to be 0. Big old donut right there. This one is copper as an ion, and so the oxidation number of the copper is going to be the same as the charge of the copper, so that'd be +2. So, see how easy this is? Woo, wow. We'll come over here, and we know that nitrogen plus oxygen equals 0. We know oxygen is -2. And I probably don't have to write this down, but I'm going to do it for the sake of consistency. N plus -2 equals 0. Add +2 to both sides. N equals +2. So I'll put a +2 for the nitrogen. Come over here. A little more difficult, but not that much. We know oxygen still is -2. We also know that the sum of all the oxidation numbers is going to equal this -1. So that means that N plus 3 times -2 equals -1. So we'll rewrite this as N minus 6 equals -1. Add 6 to both sides. N equals +5. There you have it. Okay? Part C. Start with the easy stuff. Manganese by itself with a +2 charge makes it a +2 oxidation number. Over here, we know oxygen is -2. In fact, every oxygen I'm going to see here, I'm just going to go ahead and put a -2 above each one right now. And then go from there. So this means that we have Mn plus 2 times -2 equals the overall charge. There's no ionic charge here, so that means it's going to be equal to 0. So that means Mn minus 4 equals 0. So Mn equals +4. Over here, now we have 3 elements. Ooh, imagine fun. Oh, but wait, we got hydrogen in there. So let's go back to what it says about hydrogen here. It says combine hydrogen with any nonmetal in their compound equals +1. So, is there a nonmetal here? Yeah, oxygen's a nonmetal, so that automatically gives hydrogen a +1. So now we got 1 plus N plus 2 times -2 equals, and there's no charge for this compound, so that's 0. So that's 1 plus N minus 4 equals 0, or N minus 3 equals 0. Add +3 to both sides. N equals +3. We'll put a +3 right there. Come over here. This is N plus 3 times -2 equals the overall charge here, which is -1. So that means N minus 6 equals -1. Add +6, N equals +5. And the oxidation number for that N is +5. So there's all our oxidation numbers identified. One more. This is a little bit more tricky because of the lead. Now, these are ionic compounds here. So we know that oxygen's -2. So we don't have anything special about this. We just say that Pb plus 2 times -2 equals, and that's a compound, so that's 0. So that means Pb minus 4 equals 0, or Pb equals +4. This, of course, is +2. We'll just put a +2 right there. Sulfide, SO4 2 negative. So that, and we know oxygen's -2. In fact, let's just go ahead and do what I did last time. Put -2 above every oxygen, so I don't have to go through that repetition. So this one here means sulfur plus -2 times 4 equals, and then the overall charge of this ion is -2. So the oxidation numbers have to add up to -2. So this becomes S minus 8 equals -2. And a positive 8 both sides, S equals positive 6. Now, so for this one right here, this is a little tricky, but you see that this is lead sulfate and this is sulfate. And because these are the same substance, we can go ahead and put our +6 right there. Okay? So when you identify the same polyatomic ion, its oxidation numbers are going to be the same. If it's exactly the same polyatomic ion, the oxidation numbers of all the components will be the same on both sides. Okay? What we don't know is lead. So this is Pb plus 6 plus -2 times 4 equals no charge for this 0. So this becomes Pb minus 12, I'm sorry, minus plus 6 rather. Got a little confused by all those signs there. Plus 6 minus 8 equals 0. Okay? So, that means Pb minus 2 equals 0. And therefore Pb equals positive 2. So we'll put a +2 right there. And then for this one right here, we'll do this down here. This is going to be Mn plus -2 times 4 equals the charge of this polyatomic ion is -1. So this becomes Mn minus 8 equals -1. Which means Mn is going to equal to positive 7. Now a little side note on this, that is the largest oxidation number you can have. It's positive 7. Now, I'm aware that there are a couple of instances of positive 8. We're never going to see that. Those are extreme cases. Positive 7 is the largest of the oxidation numbers, and -7 is the lowest of the oxidation numbers. So, just kind of keep that in mind. So like if you get a positive 12, something is terribly wrong. You need to redo that particular substance. Okay? So, your assignment, practice problems. This for reason you see just a little bit is on page 886. There's one number problem, number 28. There are 5 parts to it. Do all 5 parts. So I'll emphasize that A through E, because I only did 4 in the practice. See to the point where I thought I was starting to get redundant, but I wanted to show you a couple of the tricks of the trade that'll be real important in doing these from here on. Oxidation numbers we're going to be doing for this unit and the next 2 units, and a little bit for units after that. So, there it is. Have fun.